The video you're going to be watching today is on GCF, or the greatest common factor. To show you where this is used in real life, I wanted to tell you a little story about a fundraiser that I participated in. I was a class advisor, so all my students were given Gertrude Hawk forms, and once they had the forms, they had to bring them home and sell the candy. Once all the orders came in, I took a quick peek through them, and I noticed that all of the orders had peanut butter smidgens and also Jordan crackers. Once I realized this, I understood that it was something that all of the orders shared in common. When I got all the candy in, since there was a lot of orders, it was best to separate the candy by pulling out peanut butter smidgens and Jordan crackers and starting each order with these items. Once that was done, then I was able to look through the list and continue my orders. So the greatest common factor is just a great way to be able to notice a pattern or notice something that's occurring repetitively in each term, which is what we'll be looking at in factoring, or in something such as a fundraiser. It would just made it an easier way to sort and organize the candy. Now we're going to look at a problem that would require you to do GCF factoring. We have 5xy plus 10x squared y. First thing I'm looking at is, what do these terms have in common? Okay, first I'm looking at the numbers, and I notice that 5 and 10 are both factors of 5. So first thing I'm going to do is I'm going to pull out the 5 in each term. Now I'm going to look at the variables. The first letter I'm looking at is the x. The first term has 1x, the second term has 2x's, which means they have at least one x in common. The last term I'm looking at is the y. Both terms have one y. So now 5xy is my GCF. What will go in the parentheses next to our GCF is the rest of the terms, which would multiply to get the original back. If you notice, the 5xy is exactly our first term. I'm going to put a 1 there as a placeholder, and I'm going to move to my next term, and I'm saying to myself, if I have a 5, how can I make it a 10? I would need to multiply by 2. When I look at my x, I have 1x. My term has 2 x's, which means I need one more x. And last, I have y, and I have one y. So that actually is the end. These two items are both factors, which means they multiply to each other. They would also multiply back to the original. Just to show you that it works, I'm going to distribute, okay, by doing 5xy times 1, I will get 5xy. Then I'm going to distribute to the second term, and I'll get 5 times 2, which is 10. I have x times x, which is x squared, and I have a y. If you notice, that's all the way back to the beginning, so this does work. Let's look at another example. Okay, here's our new example. This time we have m's and n's. When I look at the three terms that I have m cubed, m squared, and m squared. The thing they have in common is the m squared, so I'm going to begin pulling that out as my GCF. Now I'm going to look at my n's. This term has 2, this one has 1, and this one has none. Since all three terms don't have an n in common, I'm not going to be able to use the n as my GCF, which leaves us with m squared as the only GCF. Now I'm working on my parentheses to get my original back. I began with 2 m's, I need one more m, and then I need the n squared. I'm going to carry my negative sign down. Again, I have m squared, which means I'm just needing an n. And lastly, I have m squared. I have m squared, so I just need a minus 1, which acts basically as a placeholder to then get that m squared back. Just to double check our answers, we can distribute here. I then have m cubed. I have n squared. And now I'm going to continue distributing. I have a minus m squared, the n, and then I'm going to distribute to the last term, and I'm left with minus m squared, which gets us right back to our original problem. Okay, we're going to do one more problem here to show you the GCF one last time. This time we have A, B, and C. I'm looking beginning with all of my A's. I have 3, 2, 2, which means the greatest A that they have in common are 2. So we'll begin our GCF. Now moving to B. There's 2 B's, 1, and 1, which means the most they have in common is 1B. C is 1, 2, and 1, so again it will just be 1 that they have in common. Now I will begin our parentheses. I have 3 A's, I have 2, which means I need 1 more. 1B, I have 2, I need 1 more. C is already there, so now I'm going to move to my next term, carrying the sign down. A squared, B, B, 1C, 2 C's, which means I need 1 more C. Carry my next sign down. And I have A squared, B, and C, which means I need a 1 as my placeholder. To double check myself, I can distribute this through and make sure that I get back to the original. It's always best to check your work. Okay, and that's the end of our video.